Hey everyone, and welcome. So today we're kicking off a brand new chapter, and trust me, it's a really interesting one. Three-dimensional geometry. I know, it sounds a little intimidating, but we're going to break it down and make it super simple and fun. Ready? Let's dive right in.
So, let me ask you a question. Are you ready to seriously level up your geometry game? Because that's exactly what we're about to do. It's like we're going from a flat, simple world to a massive open-world adventure. Think about it this way. Everything you did in Class 11 was 2D geometry. That's kind of like an old-school side-scroller game, where you can only move left and right, or up and down. It's totally flat. But now, in Class 12, we're jumping into 3D geometry. And this is like a modern open-world game. You suddenly get a whole new direction to play with, forward and backward. The world actually has depth now, and believe me, that's where all the cool stuff happens. But here's the thing. To explore this huge new 3D world, our old tools from 2D geometry just aren't going to cut it anymore. Nope. We need a completely new, much more powerful toolkit to figure out how to get around. So what's the most powerful tool in this new kit? Well, it's something called vectors. Now, don't get worried by the name. I want you to think of vectors as the ultimate cheat code for 3D geometry. They might seem a bit weird at first, but they're literally here to make our lives way, way easier. And you know what? This is the exact reason your NCERT textbook introduces vectors at the very start of this chapter. The whole goal, the entire point of using vector algebra, is to make 3D geometry simple and elegant. It's a tool that's designed to help you, not for confuse you.
And this quote just hits the nail on the head. Ada Morgan said, "The moving power of mathematical invention is not reasoning, but imagination." That's what vectors do. They let us imagine lines and directions in space in a really intuitive way, so we're not just stuck with a bunch of boring formulas.
Okay, so before we can start exploring, any good game needs a map, right? So let's start by understanding the basic map of our new 3D world, the coordinate system. And this is a really simple upgrade, you'll see. You already know that in 2D, a point is just x, y. Well, for our 3D world, we just add one more number for that depth we were talking about. So now, every single point in space has an address that looks like x, y, z. That's literally it. So how do you picture these three axes? The easiest way, just look at the corner of the room you're in right now. Seriously, do it. The line where the floor meets one wall can be your x-axis. Where the floor meets the other wall, that's your y-axis. And the line going straight up to the ceiling, that's your z-axis. See? They're all at 90 degrees to each other, what we call mutually perpendicular. Simple, right? Now, how do we actually find a point, say, P of XYZ on this map? It's just a simple four-step journey. You always start at the origin, which is that corner of the room, 0, 0, 0. Then you move x units along your x-axis. From that spot, you move y units parallel to the y-axis. And for the last step, you just move z units straight up, parallel to the z-axis. And boom, you found your point P. Okay, so we've got our map for finding any location. That's great, but in a big 3D world, just knowing where a point isn't really enough. We also need to know which way we're facing, which way we're moving. We need a sense of direction. And this is where that vector cheat code really starts to shine. It's like we have a built-in GPS for our 3D space. All right, the first part of our GPS system is something called direction angles. Just imagine a line, like a laser beam, shooting out from the origin. The angle this line makes with the positive x-axis, we call that alpha, or alpha. The angle it makes with the positive y-axis is beta, beta. And finally, the angle it makes with the positive z-axis is gamma, gamma. So these three angles, alpha, beta, gamma, they perfectly lock in the exact orientation of our line in space. And the next step? Oh, this is the best part. It's incredibly simple. All we do is take the cosine of these three angles. That's it. These are called direction cosines, and we call them L, M, and N. So L is just cos alpha, M is just cos beta, and N is just cos gamma. These three little numbers, L, M, and N, are like the perfect recipe that defines one specific direction. We can use them everywhere. And now for the most important property of all. This is a golden rule that you must remember. For any line in space, if you take its direction cosines L, M, and N, square each of them and add them up, the answer will always be 1. This is an awesome way to check your work. If you calculate your direction cosines and L squared plus M squared plus N squared isn't 1, you know you've made a mistake somewhere. It's a lifesaver. So, look at that. In just a few minutes, you've already collected the basic tools you need to start exploring this awesome new 3D world. Let's do a super quick recap of what you've unlocked. You're officially ready to start your adventure. All right, quick recap. We've jumped from 2D to 3D by just adding a z-axis, so now our points are x, y, z. We learned that vectors are our cheat code to make all of this super simple. To figure out which way a line is pointing, we use direction angles, alpha, beta, and gamma, and more importantly, their cosines, L, M, and N. And you're never going to forget the golden rule, right? L squared plus M squared plus N squared is always 1. You're doing great. Okay, think about it. You've got the map to find any point. You've got the GPS to point in any direction. You have the two most essential tools. So I'll leave you with a question. What do you think is the very first, most fundamental thing we can build now that we have these tools? Give it some thought, and we'll find out in our next explainer. See you then.